Let's look at when you have two categorical variables and you want to determine if they are dependent on each other, if one helps you predict the other, or if they are independent, where one does not help you predict the other one. An example of two categorical variables would be the question, do you have your own car, and what is your gender? Each of them are categorical. You have yes, no here as your options. You have male, female as your options for gender. So for this first person, it is a male who does not own a car. This next one is a female that does own a car. A male that does not, a female that does not, a male that does not, and so forth. And real quick, I want to show what this would look like if you were to start counting these up. So if you organized your a little table here into male and female on one side, and on the other side into yes and no, you could count up how many people are in these different boxes. So how many males do own a car? Well, male but doesn't own a car. Male doesn't own a car. Male doesn't own a car. Male doesn't own a car. Here's one. So we have our first male that does own a car. So that would be 1, 2, and then 3 at the bottom. So there are 3 males that do own a car. So I would put a 3 in that part of my table. And then I could go do my males that do not own a car. So I have 1, 2, 3, 4, 5, 6, 7, 8. And if you count those up, 8. So altogether I have 11 males. If I were to total it up, I would have 11 males. Now on the females, I'm going to have a yes owns a car, and 2 more yeses. So I have 4 females that own a car. And then if I count up the number of females that do not own a car, I have 1, 2, 3, 4, and that's it. So I have 4 females that do not own a car, giving me 8 total. And if I want to know how many people own a car, I could add across this way. So 3 plus 4 is 7 people own a car. And 8 plus 4 is 12 people own a car. So this table right here, and in particular this part, is going to be something that you could count up yourself, or you might be given, and you could directly enter that into StatKey. So let's go ahead and try doing it this way first, and then we'll come back and try it with the raw data and see what the raw data looks like. So if we go to StatKey, we are dealing with 2 categorical variables. So we're going to go ahead and click right on 2 categorical variables. You'll see it's preloaded with data, and it has that basic format that we were just talking about, some sort of grid or table pre-laid out for us. If we edit our data, you'll see at the top it has blank, comma, male, comma, female, meaning that across the top it has that blank square just like we did, where we have that blank square right up here, and then male, female. So actually this top row will be exactly the same as the data that was default in the system. But then the next row is going to say yes, comma, 3, comma, 4. We're going to put a comma between each of these boxes. So yes, 3, 4. And if we go back in, I can delete this other data that's in here. And I'll leave that first row because it turns out to be exactly right. But I have yes on the left, and then I have 3 in that first box, and then 4 in the next box. And then on the next line I have no, 8, and 4. So I have no, 8, 4. And I don't need to type in those totals. So I did the totals here on the side, and I actually could have even found the big total in the corner. If you add 7 and 12, you get 19. You add 11 and 8, you get 19. So you would put not 38, but you would just put the 19 from adding one direction in that box. The system will do that automatically in StatKey, so you don't need to type those in. You just need to type in this part here, the broken down part. And raw data is unchecked because this is not raw data. This is I took the time to count this out data, so not raw data, and I click OK. And then I get the same table that I was just looking at. I have male and female on top. I have yes and no on the left side here, and then it breaks down how many are in each box. and you'll see that it gives me the same information on the totals as I had calculated by hand. First thing I'm going to look at is whether or not these variables are independent of each other. Does knowing one help you predict the other? And to do that, I'm going to first look at the graph. And if I look at my males, I see that a somewhat small percentage of my males say yes, and I can show my legend here, so the brown is yes. So a somewhat small percentage of my males say yes, I own a car, and a large percentage of the males do not own a car. When you jump over to the females, it's actually half and half. So if I knew that they were male, I would be less likely to think they had a car. If I knew they were female, then it would be equally likely that they had a car or did not have a car. For a more detailed breakdown, I can look at the rows and the columns here. So, for example, if I started with the row, what the row is telling me that if I break down by male and female, my overall percentage is almost 58% male and 42% female to add up to 100% male plus female. However, of my people that say yes, I have a car, only 43% of them are male, which is a lot less than the 58 that we started with. And of the people that say no, I don't have a car, 67% of those are male, which is different than the 58. If all three of these numbers were roughly the same, then I would say that gender doesn't really help you predict whether or not they own a car. But the fact that these are so wildly different means, yeah, there probably is a relationship. There's something going on here. You can see the same thing under female. You go from 57% here when you're looking at do they own a car. 57% of the people that own a car are female. Only 33% of the people that don't own a car are female. And overall 42% of this group that we sampled is female. So you can see those large discrepancies tell you there's probably a relationship. Go to column, you're going to see the same thing, except this time it breaks it down the other way. It says of the females, what fraction have a car? 50%. Of the females, what fraction do not have a car? 50%. Of the males, what fraction have a car? 27%. Of the males, what fraction do not? 73%. So it breaks it down by saying of the males or of the females here, and on this side it says of the people who say yes, I own a car, what percentage are male? Of the people who say no, what percentage are male, female? So it breaks it down in a different way, and that's why the numbers come out a little different. The fact that the tables are not the same all the way across means there's probably some sort of dependent relationship. This overall, you could look at it, but it's probably not going to help you. It'll actually probably confuse you more than anything, so I would probably avoid it when you're trying to determine if things are independent or not.